What happens when a giant nuclear reactor comes to the end of its life? More than half of these hugely complex systems are now over 30 years old, and many have already been running for longer than they were supposed to. The answer sounds simple at first, you take it apart. But how do you dismantle something this big and hazardous, and why are some projects taking decades to complete? Well, let's take a look inside one power plant that sets a new standard for nuclear decommissioning to see how it's done. If you thought nuclear power was mostly a thing of the past, think again. Right now, there are more than 400 active nuclear reactors worldwide, and that number could grow significantly. It's a type of energy that's now considered much cleaner than fossil fuels when combined with renewables, even when you factor in the waste. That's why there's been a drive to build more power plants and maintain the ones we've got. But therein lies the problem. By 2050, almost 50% of the reactors currently in use worldwide are set to begin decommissioning. Now, in brief terms, decommissioning is the process of dismantling a nuclear reactor or facility when it's no longer needed. It involves removing the fuel, breaking down the various structures and components, extracting all the hazardous materials, and doing lots of decontamination. Afterwards, the site can either be used to put new reactors in, or for something else entirely. Why would a reactor be decommissioned? Well, it could be down to new regulations, running costs, or maybe it's in a country that's decided to phase out nuclear completely, like Germany or Italy. But this power plant elsewhere in Europe is being decommissioned for a different reason. When Slovakia joined the European Union in 2004, it did so under one key condition. Formerly part of the USSR, it would have to take apart all of the Soviet-era reactors it still had in operation, which no longer met the EU's safety standards. A pair of reactors at the V1 nuclear power plant in Bohunice, which had been running since 1978, were unfortunately on the list. They were among the first WWER reactors, a type of pressurized water design to come out of the Soviet Union. Over almost 3 decades of operation, they supplied enough electricity to power the entire country for 5 years. But after the Chernobyl disaster in 1986, the safety of early Soviet reactors became a big concern for the EU. The 2 units were switched off in 2006 and 2008. Decommissioning began in 2011, and by 2022, both reactors had been fully dismantled. As well as being paid for by Slovakia, 7 other countries have contributed to a support fund managed by the European Bank for Reconstruction and Development. In total, the project is expected to cost around $1.3 billion and is being carried out by Slovakia's state-owned nuclear company. Now, decommissioning is necessary, but still, $1.3 billion isn't cheap. Thankfully for some, it's being funded by those governments, as money from the private sector is hard to come by in 2024. Europe is still dealing with the aftershocks of the energy crisis, and the ultra-wealthy are more concerned with locking down what they have rather than splashing out for potential rewards. The richest billionaires and CEOs are building a wealth foundation that includes physical assets like gold, residential real estate, and billions of dollars worth of fine art. The QR code right here will unlock the high-powered world of art investing for you too, because that code takes you to our video sponsors at Masterworks. The art investing platform has distributed back more than $55 million in investor proceeds across their 22 exits, some of which went to investors who didn't know a thing about art. Over 900,000 members have signed up, and that number is growing by the day. With previous investable offerings from legends like Basquiat, Picasso, and Banksy, shares of some paintings have sold out in minutes. But since so many of the B1M subscribers have signed up so far, you can still skip the waitlist and start investing today by going to the QR code on screen or masterworks.art/the B1M. Now, let's get back to those nuclear reactors and find out exactly how they dismantle them. The good news is that we're not going to go over every single nut and bolt because that would take some time. Instead, here's a summary of the key phases. First up was the removal of all the systems and buildings that were no longer needed to support the dismantling of the remaining equipment. These included the turbines, the transformers, and the switchboards. At the same time, radioactive waste from the operation of the reactor was processed. More on that in a bit. Then, after a few years of this, work began on demolishing some of the structures that are more visible from the outside, like the cooling towers. They were 120 metres tall, and there were 4 of them, leaving behind 50,000 cubic metres of concrete, most of which was recycled or used to backfill the holes. Next, it was on to stage 2, which is where we find the really interesting stuff, starting with arguably the most critical component of all, the reactor pressure vessel. Inside this is where you'll find the coolant, followed by the core itself. Yes, that's by far the most radioactive section of the entire plant, where the atomic fission takes place, creating the heat that powers the whole system. A giant crane was installed to remove the vessel from the reactor shaft before it was placed into a special pool. This is so it could be taken apart remotely beneath the surface. Why? Well, because this part of the job involved segmenting highly radioactive waste, and doing that underwater meant workers were shielded from the radiation. But before these pools could be constructed, they had to make space for them, and that meant removing the steam generators, which required more heavy lifting. Believe it or not, these are where steam is produced that's used to turn the turbines, which then generate electricity. At Boanica, the generators were almost 12 metres long, weighing 145 tonnes. And there were 6 of them on each reactor. Each one had to be transported across the facility to the former turbine hall where they were fragmented, in other words, chopped up into pieces. Massive circular saws were needed to slice through the 140mm thick steel casings and the more than 5,000 heat exchange tubes inside each one. But even with the reactors taken out, the shafts left behind also had to be broken down. That's because the concrete had become radioactive as well. The solution was to cut it into blocks, smash those blocks up with a hydraulic hammer, and send the rubble away for storage. Of the more than 800,000 tonnes of material that had to be sorted through, radioactive waste amounted to less than 1%, albeit that's still quite a lot when you do the maths. So how did they get rid of it? Well, the answer was by sending it to the waste treatment centre that happens to be on the same site. Here, the waste is either separated, incinerated, compressed, or a combination of all 3 before it's packaged up and placed in containers. These are then sent off to a repository like the one at Mahortse to the east, where the waste is sealed in reinforced concrete boxes surrounded by multiple barriers. As well as storage facilities like this, there are also fuel processing plants across Europe which also have to be decommissioned when the time is right. France has one of the biggest at Le Hague, which is currently going through the process. What are the differences between this and a reactor site? Well, because there's a lot more radioactivity to deal with here, a lot of the cleanup is done remotely via operated vehicles and robotic equipment. Where humans are allowed inside, contamination is everywhere, including on the walls. To remove it, special resins are applied to the surfaces, which are then peeled off, bringing all the nasty stuff with them. Back at Boanica, the plan is to have the entire site cleared so it can be reused for non-nuclear industrial activities by 2027. In the meantime, because it became the first plant worldwide to decommission a reactor of this type, its team of experts are now sharing their experiences. With countries from Armenia to Uzbekistan now planning similar projects, learning lessons from Slovakia could help give them a big head start. Overall, decommissioning is an immense job, one that's been made a lot harder by the fact that most reactors weren't built with this step in mind. But things are starting to change. Some countries like Canada have now taken steps to ensure that any new facilities are designed with end of life as a priority instead of as an afterthought. Then there's the rise of small modular reactors, an advanced and compact new alternative to traditional reactors, which many consider to be the future of energy. They can be installed and crucially disassembled far more easily than the ones we've just seen, although they're yet to be fully adopted. So while decommissioning is a huge hassle at the moment, that might not be the case for much longer, which is just as well, because if nuclear is to become the major source of clean energy that many expect it to be, we're going to need to plan ahead. This video was sponsored by Masterworks. You can skip their waitlist at the link below. Don't forget that we're inspiring the next generation of builders through our investment into BrickBorrow, a fantastic LEGO subscription service. You can learn more and get started today over at brickborrow.com. And as always guys, if you enjoyed this video and want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.